Video here looking at empirical formula. Empirical formula, this gives us the simplest whole number ratio of atoms in a compound. I've answered some questions about this in the past when we talked about molecular formula. When we talked about ionic compounds, we always said reduce, reduce, reduce if you can, whereas molecular we said don't reduce. Because, well, this is the formula of water, this is the formula of hydrogen peroxide, and then this, a large hydrocarbon. But we said don't reduce, because this is what that molecule actually is. However, if we do reduce, we get something called the empirical formula. So this one, well, we can't reduce. But this one, hydrogen peroxide, we can reduce to just a hydrogen and an oxygen. And then this one here, C4H10, you reduce by a factor of 2, and our lowest multiple is that. So that's the empirical formula. I guess what we can do is we can find this, and then given something else, we can find this, which we'll talk about later. So how do we find this empirical formula? To determine a substance's empirical formula, we need the mass or the mass percent. So we talked about percent composition, that's exactly the same thing, of each element of the compound. So first thing we want to do is once we have that, and you should be given this or given a way to find it, we want to convert mass to moles for each element. Find the ratio. So a formula, you can't see the other board, the formula is just, it's a ratio of elements and how they fit together. So we need to find that ratio by dividing each number of moles, so that we calculated in 1, by whatever one we just calculated to be the smallest. And then use that ratio to write the empirical formula. So kind of continuing there, though, sometimes we have problems, just like I have problems moving the board. When we divide, we don't get pretty numbers. So sometimes we'll divide and we'll get a multiple of like 0.25 or 1.25. Well, for this, we multiply by, well, if it's 0.25 to get it to a whole number, multiply by 4. 0.33, same thing, to get it to a whole number, by 3. I know that doesn't give you exactly, but close enough. And this one multiplied by 2. So keep that in mind if you don't come up with pretty numbers. Also, if you come up with weird numbers that you can't really get to figure out, you probably made a mistake. So if you're not getting something like a 1 or a 2 or a 3 or something like this that you can multiply by, go back and check your math, go back and check your periodic table. There's probably a mistake in there somewhere. So let's do a couple of examples here. The first one, a compound is found to contain 9.11 grams of nickel and 5.89 grams of fluorine. Find its empirical formula. So just worrying about empirical formula here. I set it up nicely using my train tracks to find moles. So I have grams, cancel grams, I want to find moles. And for that we use molar mass on our periodic table. I did that for you. I got this many moles. Same thing with fluorine. Same exact conversion, except a different number because it's fluorine. Did my math, and we got these two things. So step 2, so that was step 1. Step 2 is divide by the smallest number. So smallest number, well, is this one. So 0.155.
Mr. Gieselman, please report to the guidance office. Mr. Gieselman, please report to or call the guidance office.
Divide by 1.55. Here, math is easy. That's 1. Here, that's 2. So here's our ratio. We have, for every one of these, for every 1 nickel, we have 2 fluorine. And then we just use that ratio to write our empirical formula, which we just said was, well, nickel was a 1. 1s we don't write. Fluorine was a 2. there's your empirical formula. And really, it's your steps. The only thing is sometimes, different compounds have 4 or 5 different elements. Just may take a little longer that way. But convert grams to moles, or convert to moles however you have to. Usually it's grams to moles. And then divide by our smallest number. This one we didn't get weird numbers for our ratios, so we didn't have to worry about doing an extra multiplying step. It just came out nicely. Problem 2. A compound contains 36.84% nitrogen and 63.16% oxygen. Find its empirical formula. Well, here we're given percent composition, so there's your tie from what we did before, and this works the exact same way. The hint is, if you see percents, just assume 100 grams, because this is going to make your math so easy. So just assume 100 grams of this compound. Well, I need to figure out grams to get to moles. It's the only way I can get there. So to get from, percent to grams, if I assume 100, of my 100 grams, 36.84% of it is nitrogen, or 36.84 grams. Same thing with oxygen. Convert to moles. So divide by molar mass of nitrogen, use your periodic table, get this number. This one, same thing, divide by my molar mass of oxygen this time, and I get this number. So that's step 1. We just had to get to step 1 a little longer. You don't have to show work for this either. Step 2, divide by smallest number. Well, this one looks smaller, so divide by 2.63, divide by 2.63. Math is easy there. Do a little math here. 3.5 divided by 2.63. This we get as 1.5. Alright, so now I have a 0.5. How do I get rid of it? I need to multiply it by 2. So let's think about this. I'll write a little different spot here. So I'm up here. So what this says right now is that I have 1 nitrogen and 1.5 oxygens. Well, we said if we see 0.5, we need to multiply by 2. So if we multiply our subscripts by 2, what we really end up with is dinitrogen trioxide in 2O3. There is our empirical formula. So this one, a little different. Given percent composition data, still do the same, assume 100%.